Okay, so I have it. The solution is there. So actually let's just go through it. First and foremost, we have the two graphs here, right? And then the green and the black. That's our first equation, right here. And our second equation is this one, right? Let me undo that one. Let's say this. Maybe that'll, yeah, there. So that's our second equation, right? So we know it touches right here, and it just touches. So you can actually think about this as if it was just a line. They're tangent to it. So if I zoomed in, it would be like right here, and the other one would be touch. And it's just touching right there. And it would be as if we could imagine a straight line, or tangent if you will, going at that, touching at that point. Ha! That, and I wasn't too far off actually sniffing around the discriminant. Because this, which is right here, will allow us to use this because it touches. Because we can think of it, it only touches it in one spot. So this has two solutions. So I was just stuck on two solutions because of these two. This has just one. I can actually get away in using this. The other thing that this problem, this is with calculus, it's trivial. So you'll see next year, year 2 will make this problem trivial, right? If I can pin it, so I kind of want to make this a little red flag here and actually pin this and use it, give it to you again next year when we're doing derivatives. Or I might even make it, put it in notes. Like put it in the notes. It's like, remember this problem that we were dealing with last year? And it was, the prof even got stuck on it. If I had my derivatives, I can easily answer this. But I actually have to do this problem with hands tied behind my back. So how do you do that? Well, we already solved most of it. So we had this. So, okay, we know where we get 1 because what we can do is, we know, use the first equation and just plug in 3 into that one, and I get y equal 1, which means it touches at 3, 1. Perfect. Right? So I denote that right there. So what can we do? We can then use the second equation, so this one. So this is our second equation right here. And I'm going to say, so this is y2 equals minus x squared plus bx plus c. Ha! Okay. And I showed you okay, I went all the way around and got this. Now it was suggested put it back into the equation and see what you did. We did it, but we just showed that 10 equal 10. That doesn't help us. And remember me journaling saying, okay, is there a second equation? Yes, there is. Second equation is this one. This is actually how we're going to use it. This problem without calculus is A, harder because of the algebra involved, and 2, well, actually there is no 2. It's just A. Because it is just, you have to be able to play with quadratics. Do you understand algebra and how to play with particularly the discriminant? Right? That's the discriminant. So, okay. Yeah, we can. So watch what we're going to have to do. I'm going to actually set the two equations equal to each other. So y1 equal y2. So what I'm going to do is just start off. Whoops. I'm just going to start off by saying x minus 2 squared minus x squared plus bx plus c. Now what I'm going to do is expand this one. So this is going to be x squared minus 4x plus 4 minus x squared plus bx plus c. This, now I'm going to put everything onto one side. And actually, I want to get rid of the c because I'm going to use this one right here. So I'm going to say this. So minus x squared plus bx. And this is going to be plus 10 minus 3b. So now I have this. Okay? So now I'm going to just put everything onto one side. So if I move everything over, so this will give me 2x squared. This will give me minus 4x. The bx has to come through. Oops. This is bx. Next is this, still there's going to be 4 minus 10. And then what we have here is plus 3b. That's all equal to 0. So now what I need to do is I'm now going to arrange it to make it look like ax squared plus bx plus c equals 0. That's what I need because I'm going to need to get my thing into a discriminant, which is delta equals b squared minus 4ac. Again, this is a lot longer and more cumbersome than what we would have to do in calculus. Very easy when it comes to calculus. You need the derivatives. This is easy. But we don't have it, so we have to play with algebra. And this is an excellent problem to do and practice your algebra skills. How good are you at algebra? So this is, then I'm going to rearrange it to look like this. So I have 2 squared. This is going to be minus 4 plus b. So I'm going to pull that apart. Then I have minus 6, 3b equals 0. So guess what? There's my c. That's c. This is my b. And that's my a. Right? Those are the components that we're looking for. So I'm going to need this because now I have it somewhat looking like that. It's just an odd looking a, b, and c. So what's my a? A is 2. B is equal to this. C is equal to something even not so nice, minus 6 plus 3b. But I all have my b's. Now, the core idea is allowing the discriminant, because it only touches, right? And that's the key. Allowed to use this. To use because it touches. Touches in one spot. Right? That's basically seeing the tangent. And the tangent is an idea that we're going to see next year, what makes it actually solve it more simply. So I'm now just going to write this down. Delta. Now my b is actually this. So minus this. That's my b squared. Minus 4. What's my a? Well, it's 2. C is minus 6 plus 3b. This means, and I know the delta is going to be 0. That because it only touches this, so that's what I'm using. This of this rule, because ab squared is equal to a squared times b squared. That's a rule. So I need this rule, which is going to allow me to do this. So this is going to say minus 1, because that's a negative 1 squared, 4 plus b squared, minus 8 times minus 6 plus 3b, right? So here's the thing, though. That's just going to be 1, right? So this is just 1. So it's going to be 0 equals 1, which is times anything. So it's just going to be 4 squared. This is going to be plus 48. No, 60. Is that 64? Did I calculate that? That's 48. So this is going to be 48, right? And then this, minus 8 times 3 is minus 24b. b. So then I expand this part. So this is just going to be 16. This is going to be plus 8b plus b squared. I expand it, plus 48 minus 24b. Now I'm just going to flip everything. Actually, I'm going to do it one more time. So 0. So I'm going to keep the 16 and 48 add together. That's going to be my 64. I'm going to add my b's together, which will be giving me minus 16. Minus 16b plus b squared. Now I'm going to flip everything. So I have now b squared. So just flip, just flip. I'll just say flip. So now we have, which won't change anything. It's just right side, left side. So then what I have here is then just going to be 64 equals 0. Guess what? I can actually factor that. Because what does it? 8 times 8. 8 times 8 equals 64. Guess what? There's my b. B. Anything, I need something that will multiply to give me 64 plus add together to give me negative 16. Well, negative 8 and negative 8 will do it. So if you test it yourself, you'll see. That means, therefore, we just have b minus 8 squared equals 0 implies b is equal to 8. Ha! That's one of them. Now we just go back to the equation. Go back to 10, or c equals 10 minus 3b. Well, c is equal to 10 minus 3. This is 8. So then c is equal to 10 minus 24. And guess what? There we go. C is equal to minus 14. And again, the problem is way easier actually doing calculus. And you'll see that next year when we start doing derivatives, which is simply the tangent. But that's how you solve the problem. And you can see this is a lot of algebra. And that's the benefit of calculus. Calculus is another tool that will allow us to make life a lot easier, more efficient, which math is all about. So there you go. So there's the answer if you want to go through it. But it's b is 8 and c is minus 14.